It's now time to address the question, where does light come from? Well, being an electromagnetic wave, it stands to reason that some kind of charged particles that are moving might be able to generate life. So at a first pass, we're going to say that light can be produced when we have electrical charges that are moving. So a moving electrical charge will produce a magnetic field, and a changing magnetic field will produce an electrical field, and so on. And so perhaps moving charges is what generates light. Well, where do we encounter moving charges? The structure of the atom. The atom has subatomic particles, some of which are charged and in motion. Let's just do a quick review. Here's the helium atom. Has 2 protons that are positively charged, and because they will repel each other, neutrons are necessary to keep the nucleus together. That's the strong nuclear force keeping the helium nucleus together. And then we have the electrons that are negatively charged, and they exist some distance from the nucleus. Now, although electrons are negatively charged and they're moving around the nucleus, this is not how light is generated. And this was a puzzle for physicists in the early 1900s. In the early 1900s, scientists used a solar system analogy to describe the structure of the atom. Electrons orbited the nucleus like planets orbit our sun. In this model, electrons could theoretically occupy any orbit or any distance from the nucleus. So if we think of the nucleus like our sun and the electrons like planets, it's theoretically possible that planets can have different distances to the sun. After all, this might be Earth here, we have a certain distance from the sun, and then there's Jupiter out here, a different distance. So on this model, the electrons could take up any orbital distance from the nucleus. But this model introduced a puzzle. Since the electrons were moving, they should be releasing energy as light. And as the electrons release energy, they're going to be slowing down. They will lose energy as they emit light. They'll lose energy, and if they lose velocity and energy, they're going to then spiral in and crash into the nucleus. Again, because the negative charge is attracted to the positively charged nucleus here. So this raised a puzzle. Atoms, on this view, should be unstable. Yet atoms seem to be stable structures. So there was something strange about electrons and what they were doing in the atom. Later, physicists discovered that electrons in the atom are restricted to certain energy levels, or orbital steps, we'll call them. Electrons cannot occupy a position between steps. In addition, electrons do not seem to lose energy while in a particular energy level. And this is still sort of a puzzling discovery about atomic structure. It's part of a theory of physics called quantum mechanics. So here we have the proton. Now we're looking at a hydrogen atom, 1 proton. Here's its 1 electron, and it's existing at this orbital level here, what we'll call the lowest energy level, or the ground floor, the first step in a staircase of steps. So the idea is that the electron in a hydrogen atom can exist at this energy level, or this one, or the next one here, or the next one here, but not in between the steps. And whenever an electron is on a step, while we might think of it as sort of moving, it evidently does not generate light when it's on a particular step. However, these electrons can move to higher steps, and the movement to different steps is associated with light. So here we have the hydrogen atom with its 1 electron on the lowest step, and here the electron is on a higher step, and we would say the electron is at a higher energy state on this higher step. Now how does an electron get from the lower step to a higher step? Well, it takes energy to bump an electron to a higher step, and one way to supply that energy is to heat up the hydrogen gas. Here we see a tube of hydrogen gas, and it's going to be hooked up to a voltage source. So they're going to, in a sense, produce an electrical current through the gas. It's called a hydrogen discharge tube, and you can fill this tube with any kind of gas. And when you send that electrical current through, it effectively heats up the gas, and that forces more energetic collisions between the atoms. And these collisions then can bump those electrons up to higher energy levels. The gas glows with a characteristic color. So somehow creating more energetic collisions between the hydrogen atoms is causing the hydrogen to emit light. So here's the idea. We heat up the hydrogen atoms so they're colliding with each other, and those collisions can bump an electron up to a higher energy level. And when the electron is in the higher energy level, at some time later, it will jump back down to the lower energy level. And that jump back down to the lower energy level is associated with the release of light. So when an electron jumps back down to the lower step, energy is released as an electromagnetic bundle of wave-like energy, a photon of light. So at this point then, atoms can absorb energy in the form of heat, for example, more collisions and so on, and release that energy as light. So here's a summary of that process. Here we see the nucleus of the atom. Let's say it's a hydrogen atom, so there's one proton here, and here's its electron. Well, let's say some particle hits the atom, or it could be another hydrogen. You've heated up the gas, and the hydrogen atoms are bumping around. Well, that can cause the electron to jump up to a higher energy level, and it'll exist in that state for a while. But when that electron jumps back down to the lower energy level, a photon of light is emitted. So the hydrogen gas is glowing because electrons have been excited and are now jumping back down to lower energy levels. And that releases certain colors of light. And we'll figure out which colors of light get released in the next lesson.